A car of mass 1.40 times 10 raised to the power 3 kg being towed has a net force of 4.5 times 10 raised to the power 3 newtons applied to it. The car starts from rest and travels down a horizontal highway. Find the work done by the force after it has traveled 1,000 meters. Ignore kinetic energy losses by friction and air resistance. Now, we have to understand the problem. We have a car of, this is from mechanics. We have a car of mass 1.4 that's what we're given, being towed has a net force of 4.5 times 10 to the power 3 newtons applied to it. So let's take that direction to be the direction in which the car is being towed. So we have a net force moving in that direction of 4.5 times 10 to the power 3 newtons. The car starts from rest and travels down a horizontal highway. Find the work done by the force after it has traveled 1,000 meters. So let's say it starts from u is equal to 0 and travels for 1,000 meters. So let's say distance s is equal to 1,000 meters, right? Maybe let's give it that something. Let's just imagine it ends there, right? So we're asked, find the work done by the force after it has traveled 1,000 meters. So the key thing here is that we are told that a net force, this is the net force, right? And then we're going to ask, this is the net force acting on the car. And what about this mass of 1.4 times 10 raised to the power 3? Well, the mass, of course, is going to result to a weight, but that weight is going to act perpendicular to the direction of the force. So it's not really going to add to the net force, right? So we can pretty much ignore this in this problem. The key thing here that we need here is the net force and the distance traveled. And if we remember from our work formula, if one of the formulas for work done is force times distance traveled in the direction of the work done, or distance in force times distance in the direction of force. Distance direction of force. So in this case, the net force is 4.5 times 10 raised to the power 3 newtons. Okay, we can ignore the units here. Times distance, 1,000 meters. We have to be careful. The units are standard, 4.5 times 10 raised to the power 3 newtons and 1,000 meters. So we can sum it and have 4.5 10 raised to the power 6 Newton meters, right? Or 4.5 times, or it's Newton meter is also equivalent to joules, which is also 4.5 times 10 raised to the power 6 joules. So that's the work done, and that's why our answer is option C.